Hello everybody, let's come back to our discussion on the ecosystems under unit number 3. The ecosystems are, as we said, subsystems of a larger system called environment, and each subsystem, like I was giving the example of a village where we have a potter, we have a weaver, we have a singer, and we have a paddy producer. Each one of them give and take, what in economics we call it as a barter system. Barter system whereby each one produces certain amount of goods, and then finally these goods reach the consumers and they fulfill their each other's needs. The dependence on each other is the key for the overall ecosystem to survive. So in ecosystem, if we classify these subsystems or eco subsystems, we can call them as producers, consumers, and decomposers. I'll explain the producers, consumers, and decomposers in a particular ecosystem. If you take, for example, the potter again, the agriculturist, he does a lot of activities in being an agriculturist, in producing paddy or chili. Now, what all he does are his processes. What all he does are the processes. Now, he gives these goods to somebody who is a consumer. That consumer may or may not produce the paddy or potter. He would not produce because there is somebody else to produce it. He consumes it. So, he is a consumer. That decomposer, in the process of making these goods, you will get some unwanted materials. Those unwanted materials have to be disposed. Therefore, we have in summary, we have producers, consumers, and decomposers. Let's deal with this particular phraseology in detail. Now, producers in the nature, well, we talked about the paddy producer and potter and singer in the village, but if you look at the natural environment, there are certain organisms meaning human beings, animals, viruses, insects, birds, and so on. So these are the living organisms which are there. Now, we have trees, we have fungus, we have algae, and we have non-living things like mountains, air, water, fire, and all these things. So therefore, let us classify them into our 3 groups: producers, consumers, and decomposers. Now, producers are those people who make the goods for the first time. He doesn't take it from anyone else. Like, for example, if you take trees, trees take sunlight from the sun, trees take water from the ground, trees take nutrients like nitrogen and phosphorus from the ground and undertake photosynthesis, which gives out oxygen and necessary energy to maintain the life of the tree. So this is the process of the tree. So tree becomes a producer, a primary producer, because tree is not using any other produced goods in making of its photosynthesis. It is only taking from the nature. So when you take inputs from the nature, when you make goods for the first time, you become a producer. Example, trees. Now, what are the trees giving us? Trees are giving us fruits, trees are giving us timber, trees are giving us leaves, trees are giving us rubber, trees are giving us gum, and many other medicinal products trees are giving us. Now, these products coming from the trees and plants are used by either human beings or many dependent systems. Therefore, we become consumers. Consumers are the people who do not make their own goods, but they use the goods produced by producers. Producers are the ones who make the goods from the nature, from the inputs from the nature like sunlight and the photosynthesis. Having made it, the fruits are used by human beings, for example. Therefore, human beings are consumers. Now, after the human beings consume, what happens is there are certain unwanted materials which are produced. For example, human beings, when we consume the fruits or other goods, other materials produced by the producers like trees and plants. We consume those products, paddy, rice or food we take, and then we produce some unwanted materials like sweat, for example, our sweat, other excretions that the human body does. Now these materials have to be decomposed. They cannot be let into the atmosphere just like that. They have to be decomposed. Now there are certain worms, certain other organisms which consume these things, which act upon these things, and then they decompose these unwanted materials. Therefore the nature is able to replenish itself. Look at how beautifully the God has made the system. Somebody is making the original product, somebody is consuming, in the process somebody is leaving out the unwanted materials. That unwanted material will create problems to the nature. Therefore nature itself has provided a way whereby these unwanted materials are decomposed. Decomposition means, composition means to put it together. Decomposition means to make it individual, is to separate it. All the chemicals, all the atoms and subatoms which are there in that will be separated, decomposed, so that it doesn't become a waste material anymore. It becomes its individual parts like nitrogen, oxygen, carbon, phosphorus, whatever it is, and they go into the nature because they are anyway part of the nature. In nature we have all these, so these unwanted composite materials are decomposed, and you have these agents, these ecosystems which decompose these materials, which are called decomposers. We have bacteria which are decomposers. A lot of bacteria act upon these waste materials and separate them into individual parts. Therefore we call them as decomposers. All right. So we have producers, we have consumers, we have decomposers. Let me sum up again. Producers produce the goods or output like paddy and matka from the nature's materials. Those materials are taken by the next agent called consumers, who consume, who don't produce but consume, and in the process certain unwanted materials are generated which are decomposed by viruses and things like it. They are called decomposers. So we have talked about producers, consumers and decomposers in the ecosystem. Now we have already said consumers, they are called carnivores, C-A-R-N-I-O-R-E-S. Carnivores are the people who consume the primary products. Therefore, like wolves, they are the people who consume the materials which are given from the, I was giving you the examples. Now decomposers are, as we said, they are bacteria, they are fungi and things like that. Suppose if any disturbance happens to producers, consumers and decomposers, what happens? What happens is that particular activity, if an agriculturist doesn't work during the season, or when the process is on and he is not able to go to the field and he is unable to produce paddy, you will not have rice to eat. Simple. There will be a disturbance. You will start eating something else. You may eat wheat, or you may eat something else. You may live on fruits for a few days and so on, but then there is a change in your life cycle. That means if there is a change in your life cycle, the kind of output that you give is different, the excretions are different, therefore the input which is coming to decomposers is different. So whole thing gets disturbed. So what we are saying here is, there is a beautiful cycle arranged by nature for producers to produce. Producers are the people who take from the nature and then make goods, consumers to consume, decomposers to decompose, and they operate in a particular rhythm, particular cycle, so that the nature's whole activity, the air, water, fire, the forests, the oceans, the sun, moon, everything that we see is intact because everything contained in these entities are reduced to producers, consumers and decomposers, and their activity goes on like a perfect life cycle, and only when those activities go on you have the nature's overall balance maintained. That's how the producers, these things are very important. Now what happens is when producers are producing their goods, consumers are consuming, and decomposers are decomposing. Now what happens when the everything is energy? As we know, the law of conservation of energy, okay, energy can be neither destroyed nor produced. One form of energy can be converted into other form of energy. So what is happening in the whole process of producing, consuming and decomposing is nothing but conversion of energy. In the ultimate, what is happening is the certain chemical reactions taking place, certain processes happening, and all this can be equated to conversion of energy from one form to the other. So there is a flow of energy in producing goods. There is a certain flow of energy which is happening. Energy is not this electricity and this horsepower that we are talking about. We are talking of at a atomic reaction level, at a molecular reaction level. What happens is the flow of electrons, the flow of energy and their energy, so that everything can be understood in terms of energy flow. So this energy flow happens in several levels. Okay, these levels are put in the form of a pyramid, a physical triangle that is called energy pyramid. Okay, something will be at less per some system consumes 1%, next system consumes 10%, next system consumes 20%, final system consumes 80%, and whatever it is, while these subsystems or ecosystems are interacting with each other, depending on each other in producing, consuming and decomposing, they are using the nature's energy, and this energy is not equal in all the subsystems. This energy can be quantified and said to be X, Y, Z, or 10%, 20%, 30%, 50%. All this, if you arrange in the form of a triangle, it becomes a pyramid. So that pyramid is called energy pyramid. So in the concerned PPT, you will see a beautiful diagram whereby the consumers, the producers and the decomposers are shown. Sun's light energy is shown, so that everything how it transmits is shown in the pyramid. You can have a look at the energy pyramid. Now from the energy pyramid, what we understand is the energy flow is the root cause of the processes which are happening in the subsystems, and these processes are not equal in their quantum of energy. These processes use less, more, much more, and everything kind of differentiated energy requirements of these subsystems. Those energy subsystems fall into one pyramid, and that is called energy pyramid. Okay, we talked about this fine, and then we go to the next sub topic called ecological succession. Okay, now let's understand these two English words called ecological and succession. Ecological pertaining to ecology. Ecology means the sum total of all the living and non-living things around, and succession means moving from one stage to the other. In the organizations, in a company, for example, succession in your family, in your village, for example, father is the one who started, grandfather is the one who started, and when the grandfather retires, your father has taken over that activity, and when your father retires, you have taken over. When you have taken over, when you retire, your son would take over. So it is one after the other. Succession means one after the other. So we have ecological succession in the ecological systems also, ecosystems, so we call in the ecosystems also, there is in the life cycle of the ecosystems there is a succession which is taking place. Okay, forests, for example, if you take, forests are not ready made as we see them today, that God has sent them from heaven and one fine morning you have the whole green forest in front of you. It's not like that. Forests have evolved over billions of years. Forests were some other entity to start with. They became something else, later on something else, and so on. Okay, you have plants, you have grasses, you have shrubs, you have trees, and you have hardwood trees, you have eucalyptus, you have much bigger trees which are in the process of evolution, which is called succession. Okay, so ecological succession is a sequence of processes wherein the ecosystems rebuild themselves into the next higher organisms. The nature has provided a beautiful way in which minor organisms evolve into major organisms. Human beings, for example, we were not like this a few billions of years ago. We were in some other form, but we have become this today over billions of years. The change has occurred in our biology, and then we have become what it is today. This is called succession. Okay, development of organisms from one stage to the other, from minor to the major and much major, is called ecological succession. It happens as a part of the nature's beauty, nature's existence. Now, examples that you have to write in your examination is how the forests have evolved from a fungi to shrubs to plants to trees and bigger trees. The next example is human beings from living cells to composite entities to little animals to dinosaurs. You know dinosaurs? Dinosaurs are the living organisms, major living organisms like us, which existed long ago. Dinosaurs. From the dinosaurs, again some other form of human beings evolved, and finally we are here. So therefore, you have the evolution process which is called ecological succession, and this is time bound. The ecological succession will not have randomly, will not have erratically. They have got a time frame within which it happens. Man, for example, has evolved over billions of years, and trees have evolved over trillions of years, and so on, because when the Big Bang happened on this planet, there was nothing. There was nothing except some lava and then some gases and some which formed into your molecules and atoms and so on. Nothing. They came together to form a cell, a living cell. That living cell created the whole thing. So therefore, we understand the ecological succession. You can have a look at the diagram. Now, these ecological successions of the ecosystems, they need input in order to make their processes. For example, human beings, we want food in order to survive, in order to breathe, in order to excrete, in order to reproduce, whatever it is. For all our human activities, we need food. Okay. Now, the food is in the form of energy. If you decompose food, what happens is you get molecules and energy. All right. The flow of energy in an ecosystem is the process, and the sequence of these processes is called the food chain. Okay, the food chain, if you look at the food chain or energy chain in the living organisms, for example, look at the sun. From the sun, plants take energy, sunlight and energy, and they also take minerals and water from the ground. They produce their own food, they do photosynthesis, they produce their own food, and they give to the next consumers like insects and animals, and we consume them and give it something else. And this process is called a food chain, because plants, we depend on plants. Also plants give us food. Somebody else depends on us, the bacteria or the other living organisms which consume the output of us and then decompose them. It is food for them. So output of A is input for B, output of B is input for C, output of C is input for D, and so on. All the systems and subsystems which are existing in this nature become suppliers to each other, consumers to each other, decomposers to each other. The beautiful way the nature has formed itself, and the flow of food and inside energy from one to the other is called a food chain. Now, is there only one food chain? No, there are several food chains, because the food chain of plant kingdom is one, the food chain of living organisms is other, and within us living organisms, again the food chain of the organisms living in oceans is different, the organisms living in under the trees, bacteria, viruses are different. The organisms living within human body, there are several organisms living within our human body. They have an energy chain, food chain of their own. The sum total of all these food chains is called food web. Web means World Wide Web. What do you mean by WWW, World Wide Web? We use internet so much. It is called web because there are so many internets which are put together. Okay, if I make an email from now, it goes to the operator, from the operator it goes to the service provider or BSNL, whatever. Okay, from there it goes to the satellite. This particular process which I am doing singly, it goes to satellite. From the satellite it hits back, it comes back, and when it comes back, because the satellite is seeing the whole earth, this signal of mine is seen by, perceived by, received by everybody simultaneously. Therefore, my email, my word, my signal which I am producing here is simultaneously seen throughout the world. So therefore, that is called web of webs, internet, net of nets is called internet, web of web is called the total web. Okay. So the food web in our, if you come back to the ecosystems also, you have food web of an entity A, like human beings, food web of food chain of trees, food chain of bacteria, food chain of other carnivores or otherwise. All these food chains put together is called food web. So we have defined food web also, and you have many other forest, other subsystems, number of subsystems. It's countless. We do not know how many ecosystems, how many subsystems, subsystems are there in the nature. But then it's very interesting to study, know more and more about this nature. That's why this subject becomes a beautiful, very interesting, very exciting subject, this ecology and environment. Now let's look at some more aspects of this ecology and environment. these ecosystems, I have been talking about these ecosystems, their energy flow and food flow, energy pyramid and food web and all this. Let us look at the major subsystems in little more detail. Okay. Now we have already said that there is a forest subsystem. Okay. Let me read it out for you. A forest subsystem is a unit of living organisms, plants, animals, microorganisms, all interacting among themselves and with the environment. Environment is soil, climate, water, light, fire and air and everything, in which they live together. We have a forest subsystem. Forest essentially means the plants, the trees and the other organisms living in that. Don't misunderstand forest as only the conglomerate of trees. No, forest includes the trees, plants and other plant kingdom entities, and also the animals, the insects, bacteria, birds and everything living also which is there in the amongst these forests. That is called a total forest. Okay. Let us have a comprehensive view of the forest. That is called forest ecosystem. Now again, remember that in the forest ecosystem, all the organisms which are living within the forest are interdependent. That interdependency is very important. That is why we studied the food chain, the food web and the energy chain and the energy pyramid, because we believe that it is the interdependence which is the root cause of sustaining this nature. If the interdependence between the organisms is broken, the nature is broken. Something comes. We had seen tsunami, we had seen forest, we are seeing coronavirus today. The virus has come because something has happened somewhere, some disturbance has taken place, therefore the virus has happened. Now if you look at forest ecosystem in much more detail, now the forest can be classified as tropical forest, temperature forest and boreal forest. Tropical forest, TROPICAL, tropical forest. Temperate forest, TEMPERAT, temperate forest. Boreal forest, BOREAL forest. Okay. We are studying the forest ecosystem in detail. We said forest is nothing but an entity where you have trees, plants and other living organisms living together, interdependency, which is it's like in a village. Again, you have so many people, so many professionals, so many activities going together, living together. Simple. This nature is also a village. Okay, we have so many subsystems which are interdependent on each other. That is what simply we are saying. Now coming to that, we are studying the forest ecosystem in much more detail. We have said forest is nothing but a totality of trees and plants and other living organisms which are living in an interdependence. That last word is important, in an interdependence. Okay. Now we classified the forests as tropical forests, temperate forests and boreal forests. Now let us see one by one in detail. Now tropical forests are the trees and their other entities which exist in high temperature zones. For example, what are the high temperature zones? If you look at, is Canada a high temperature zone? Is America is a high temperature zone? Switzerland? No. If you look at the earth, from the middle of the earth, okay, everything down is high temperature. Okay. Asia, for example, within Asia you have Africa, you have India, you have Indonesia and so on, which are tropical regions. Tropical region, by tropical what we mean is high temperature. The sun's rays fall directly at a shorter distance or with more intensity or in an angle whereby they produce more heat. Therefore, these regions like Asia are called tropical regions, and the plants and other entities which live in these tropical regions are called tropical entities, and their characteristics is that these tropical forests are having high temperature through most of the year. Even in winter our temperature is much higher. Here in Hyderabad, for example, or in India, for example, the average temperature in India even within winter could be something like I would say 15 to 18. The 15 to 18 is hot summer in some of the countries. So therefore, we are stated to be the tropical region. In this tropical region, these woods are dense woods. Okay, these forests are characterized by their ways and means of taking water, and for example, the human beings, we don't take much water in winter, but we take a lot of water in summer. Like the trees also, because they are tropical trees, our mango tree is a tropical tree, our subabul, casuarina, these are all tropical trees which are planted here, which are grown in Asiatic countries. They are called tropical forests. Okay. Now the tropical forests are the forest wood trees which are having dense wood. In a given area you have massive mass of wood, and they are little shorter. The trees are little shorter, their wood is little thick, their outer layer is also thick, and because of temperature, to resist the temperature, probably even our animals, if you look at the cows, if you look at the sheep, okay, if you look at these things in tropical areas, they have denser outer layer. Okay, our skin is stated to be a little thicker compared to others anyway. Therefore, we have these tropical forests which are characterized by density of the pulp, which are characterized by their short height and small and wider leaves. Now we have the other thing. They are typically, what are the examples of the plants on trees which are in tropical areas? You can write our mango, you can write our subabul tree, you can write our neem tree, whatever it is. These are the trees which are grown in tropical areas. These are the examples. The next, this thing is temperate ecosystems. Temperate ecosystems are the ones which are grown in much more higher temperature zones. We have, for example, Africa is a high temperature zone, okay, where Bhadrachalam, if you take within Telangana, if you take Bhadrachalam, where the temperatures go up to 48 to 50 degrees during the summer. So therefore, the trees which are grown there, the people who are grown there are habituated to the kind of water they take, the kind of life they have, their life cycles, their food systems and so on. So the tropical are the medium temperature forests, temperate or the high temperature forests, and accordingly you have those things, because I had been to Africa. So in Africa, the kind of trees that you have, they are very, very huge trees, and they are very, there are trees which you can't cut very easily. All right. Now boreal forests, the next one is a boreal forest. A boreal ecosystem is an ecosystem with a subarctic climate located in the northern hemisphere, approximately 50 degrees to 70 degrees northern latitude. These ecosystems are located in boreal forests, which are commonly known as the taiga forests, or which are known in Europe, mostly in Europe, America, Canada. For example, if you take Canada, is a boreal forest. Canadian forests are boreal forests, American forests are boreal forests, because they are grown in the colder regions. Their trees grow very long. They create coniferous trees, for example. They grow very tall. If you look at it, it looks as if it is touching the sky, the boreal trees, and they live in low temperatures. They grow very tall, but their pulp yield, their compactness is very less compared to the tropical trees. And these boreal, the temperate or tropical regions are also classified as coniferous and deciduous trees. Coniferous are the ones which are grown in the colder regions, and the deciduous are the ones which are grown in the hotter climates. Okay. Now, what are the characteristics of, for your examination purpose, let me summarize the characteristics or features of forest ecosystem. These forest ecosystems, they are stretched in an open land. They use renewable resources like groundwater and sunlight. They have multiple uses. They have, the uses of trees, I need not tell you, and their life cycles are very long. For example, there are trees which live beyond 100 years. There is a banyan tree which lives 400 years, and so on. Some of the trees of the ecosystem, the forest ecosystem, are very long, okay, and some plants, of course, very small. Now, what are the structure of these forest ecosystems? The forest ecosystem is the primary producer. It takes energy from the sun and from the ground. It produces certain materials, and this material is used by consumers like human beings and other animals, and it goes on to decomposers. So, this is the structure of the ecosystem which you need to write in a short answer question. The next one is grassland ecosystem. We have forest ecosystem, we have a grassland ecosystem. Grassland ecosystem is nothing but vast stretches of grass. Okay. In India, we often don't see huge grasslands, but if you go to colder regions, the huge 100 miles, 200 miles, 300 miles of land is just a grass. Only grass is grown, nothing else. Only grass is grown, nothing else. They are called grassland ecosystems, and they are grasslands are usually grown in open air. They don't need any protection, they don't need anything. They grow from the ground on their own. They grow from the ground on their own, and there is a quick cycle. The life cycle of grass is shorter than the life cycle of banyan tree, for example, or a coniferous tree or a eucalyptus tree, and they produce their own offspring. Now, the pollens are fallen on the ground, again the pollens produce. So, the shorter life cycles they keep on producing. That is the characteristic of grasslands. We must, what are the characteristics of grassland? Shorter life cycles and self reproducing mechanism. You have biotic and abiotic grasslands. Okay. In ecosystems, we also classified in the previous class, if you remember, in the first or second class, we said ecosystems can be also classified as biotic and abiotic. Okay, BIOTIC, biotic, and ABIOTIC, See, abiotic. Biotic are relating to life. They have life. Okay, it's like living cell, like human beings are biotic. Bio means relating to the living cell is called bio. So all those entities which are with living cells is called biotic grasslands, and abiotic grasslands are the ones which you do not have much grass there. Okay, it's just a vacant land. It's just a vacant land, and it's abiotic because there is no life or plant or anything on those. It's a vast stretch of lands. So you have grasslands of two types, but there may be some small living structures may be there, creepers and some this thing, but you do not have a huge mass of grass spread over hundreds of hectares, like you have a green cover. There is no green cover in the abiotic grassland systems. You have grass which grows and which is dry, and which is small grass plants are there. That's called abiotic grassland, because the biotic activity is not taking place in the abiotic grasslands. It is not that in the grassland you have plant and you have germs and you have viruses which are again dependent there, as I mentioned earlier, but in the abiotic grasslands you do not have the huge activity of biological processes which are so interdependent happening day in and day out, because it is abiotic. Abiotic means lifeless. In other words, crudely, if you look at the dictionary meaning, you will find abiotic means lack of life, L-I-F-E, life. Biotic means full of life. So you have biotic and abiotic grasslands. Now, what are the functions of these grasslands? They provide grass. To be in our villages, if you see, we used to send, in my childhood, we used to send the cattle to the open lands. They are grasslands in a way. They go, and one fellow, the boy goes with them, and then they throughout the day they are grazing, and then they come back. So that grazing is an activity, as a function which is happening, and of course they provide the food for the bacteria, food for the viruses, food for snakes, food for ants, and food for beans. So all these functions the grasslands are doing. They also give out oxygen, some things like this, which often is not found in the textbooks, but I would say that the grasslands are one big source of oxygen. In their photosynthesis they give out a lot of oxygen, like trees. So we have functions like production of oxygen, we have functions like food for the minor organisms, we have production like providing grass for the animals, and in some of the grasslands you have some plants, some grasses which grow taller. In my childhood I used to go and cut them and get it. My house was thatched house which was covered with the grass. Okay, so that is another function if we can ascribe. Okay, so the grasslands provide the rooftop for in the villages. In Africa also I have seen lot of the living hutments, thatched houses are covered with grass. So where is the grass coming from? Grasslands. Okay, the smaller one, and the grass grows up to, sometimes the grass grows up to my height also. So that is cut and then dried and used as coverage, or the roof house top is covered with that. So these are all functions of grasslands. Okay, so we have seen the ecosystem today, and we have talked about food chain, we have talked about energy chains, we have talked about the web of web, we have talked about the organisms which produce their own food, producers, organisms which depend on other organisms for food, which are consumers, organisms which use the output of the consumers and then decompose. They are called decomposers. And now we are seeing the subsystems, the forest subsystem. In the forest subsystem, we have talked about 3 functions. We have talked about the functions of grasslands. We said they produce energy, they give rooftop, they give food for things, and we have also seen the types of forests. We have seen tropical forest, the temperate forest, and we have seen other types of forests, boreal forests. Therefore, the forest system in its entirety at BBA level, at this course level, we talk of only these introductory things. We do not go into the technology of photosynthesis or other processes. For example, we do not go into that, but then the basics are understood in this way. So today we have completed the subsystem called forest ecosystem. Okay. We have other ecosystems which we will see in the next class. Thank you very much.